If humans had to get all their caloric energy from the sun just like plants, how wide would we have to be? The short answer is, you would be dead. But before you died, you would be a terrifying, translucent, green sheet of flesh roughly the size of a tennis court, screaming silently as a gentle breeze folded you into a biologically origami nightmare. You see, we tend to romanticize nature. We look at a tree and think, wow, free energy. So peaceful, so efficient. But that is it. Nature isn't peaceful, it's a violent scramble for scraps. And photosynthesis, it isn't a miracle. It is barely functional garbage that evolution stuck with because it couldn't come up with anything better. So grab a sandwich, which is just concentrated sunlight that a cow kindly pre-processed for you, and let's ruin your day with physics. To understand why you can't just eat the sun, we first need to look at the thermodynamic disaster that is the human body. You are fundamentally a combustion engine. You put fuel in your face hole, your mitochondria break the chemical bonds, and you harvest the energy to keep your heart beating and your brain anxious. A standard human needs about 2,000 dietary calories a day. In physics terms, because we don't use units based on burning donuts, that is roughly 8.4 million joules of energy. If we average that usage out over 24 hours, your body is running at about 100 watts. You are a slightly bright, very moist light bulb. Now 100 watts doesn't sound like much. My gaming PC draws more power than that just displaying the desktop. But the density of that energy is key. A single Snickers bar contains about 1 million joules of chemical potential energy. You can eat it in 30 seconds. Sunlight, on the other hand, is dilute. The sun is a screaming nuclear fusion reactor 93 million miles away, blasting the Earth with high-energy photons. But by the time that light filters through the atmosphere, hits the ground, and bounces off your bald spot, it's not nearly as punchy as a candy bar. Let's maximize your odds. Let's strip you naked and paint you green. We are going to replace your melanin with chlorophyll. Congratulations, you are now Photoman. At high noon, on the equator, on a cloudless day, the sun hits the Earth with roughly 1,000 watts per square meter. If you were a perfect solar panel, a black body absorbing 100% of that energy and converting it all to electricity, you would only need to be the size of a dinner plate to survive. But biology is not a solar panel. Biology is wet, squishy chemistry, and chemistry has rules. Plants are shockingly inefficient. The theoretical maximum efficiency of photosynthesis, the Shockley-Queisser limit of the plant world, is about 11%. But in reality, most plants operate at roughly 1% to 3% efficiency. They are terrible at their jobs. Let's be generous. Let's say we genetically engineer you with super algae skin. You operate at 5% efficiency, so the sun gives you 1,000 watts per square meter. You can only use 50 of those watts. To hit your 100-watt survival target, you need 2 square meters of skin facing the sun directly. That's actually not too bad. An average adult male has a skin surface area of about 1.9 square meters. So, if you lie perfectly flat naked at high noon on the equator, you might just barely survive. However, there is a problem. The sun moves and sometimes the Earth rotates. In fact, the Earth rotates roughly once per day, which is very inconvenient for your metabolism. You can't photosynthesize at night, so you need to store 12 hours of battery life during the day. Plus, the sun isn't always directly overhead. The average solar irradiance across the entire globe, accounting for 9 angles, is only about 170 watts per square meter. Let's rerun the math. 170 watts coming in, 5% efficiency. That gives you 8.5 watts of metabolic power per square meter of skin. You need 100 watts just to stay alive. 100 divided by 8.5 is roughly 11.7 square meters. To get enough sunlight to survive, you can't look like a human anymore. We have to stretch you. We have to roll you out like pizza dough. You are now a pulsating green biological tarp, roughly 3.5 meters by 3.5 meters. You are the size of a small bedroom. But wait, that's just to lie in a coma. That's your basal metabolic rate. Do you want to walk? Do you want to think? Do you want to scroll on your phone? That costs extra. If you want to live a normal active life, burning 2,500 calories, we need to widen you further. You are now a 5 meter by 5 meter sheet of flesh. Here is where the physics starts to hurt. Square cube law is about to ruin your life. By flattening you out into a giant festive placemat, we have maximized your surface area while keeping your volume the same. You are now mere millimeters thick. The first problem is structural integrity. You have no bones. Bones are heavy and opaque, they block the light. You are essentially a jellyfish spread over a parking lot. If a gust of wind hits you, you don't just get cold, you act like a sail. A 10-mile-per-hour breeze would generate enough lift to rip your connective tissues apart. You would crumble like wet tissue paper, but the wind is the least of your worries. The real killer is water. Photosynthesis requires water. The chemical formula is carbon dioxide plus water plus light equals sugar plus oxygen. You need to split water molecules to get the electrons to drive the reaction. Plants solve this by sucking water from the ground. But you are a human. You don't have roots. You have legs, which are now useless flippers on the edge of your body. Because you have massive surface area, You are evaporating water at a rate that is medically classified as hilarious. You are a giant cooling tower. To keep your photosynthetic membrane turgid and functional, you would need to drink roughly 200 liters of water a day. Since you can't move because moving costs energy you don't have, you just have to hope it rains. If it's sunny enough to feed you, it's hot enough to desiccate you. You are a raisin waiting to happen. And God forbid a cloud passes over. If a cloud blocks the sun for 10 minutes, your power supply drops to near zero. A plant handles this by going dormant. A human, your brain consumes 20% of your energy. If the voltage drops, you pass out. So picture this, you are a 25 square meter sheet of shivering in a field. A cumulus cloud floats by. You instantly lose consciousness. While you are out, a neighborhood dog wanders by, thinks you look like a nice astroturf mat, and relieves himself on your torso. The ammonia burns a hole in your lung. You wake up, but you can't scream, because your diaphragm is stretched so thin it can't generate air pressure. Now, you might be asking, Mr. Science Man, why is photosynthesis so bad? Why only 5% efficiency? Solar panels are like 20% efficient. It comes down to an enzyme called RuBisCO. RuBisCO is the most abundant protein on Earth. It is responsible for fixing carbon from the air so you can turbine from the mess. It is also, chemically speaking, an idiot. RuBisCO is supposed to grab carbon dioxide, but about 25% of the time, it gets confused and grabs oxygen instead. This creates a toxic byproduct that the plant has to spend energy to clean up. It's called photorespiration. Imagine a factory worker who tries to build a car, but every fourth time, he accidentally sets the car on fire and has to spend the rest of the afternoon putting it out. That is the foundation of all life on Earth. Evolution hasn't fixed this because evolution isn't an engineer, it's a hacker. It found a code that barely compiled 3 billion years ago and said, good enough, ship it. If we wanted to make you a good solar human, we wouldn't use chlorophyll. Chlorophyll reflects green light, which is right in the middle of the solar spectrum. That's stupid. You're throwing away perfectly good photons. To be efficient, you should be pitch black. You should absorb every wavelength. If we make you a perfect blackbody photosynthesizer, we can shrink you down. But now you have a new problem, heat. Absorbing all that light means absorbing heat. Plants stay cool by evaporating water. But remember, you're already thirsty. If you were a blackbody superplant, you would cook yourself from the inside out. Your proteins would denature. You would essentially susvide your own organs. So, let's summarize your life as a photosynthetic human. To survive, you have flattened yourself into a giant, immobile green membrane the size of a studio apartment. You spend your entire life terrified of clouds. You have to drink a bathtub of water every hour. A stiff breeze will rip you in half. And you are constantly on the verge of starvation because a prehistoric enzyme inside your cells keeps mistaking oxygen for food. And the worst part, you can't even enjoy the sun. You have to stand there taking it, maximizing your surface area, while the rest of us sit in the shade eating tacos. The beautiful thing about being a heterotroph animal that eats other things is that we let the plants do the boring, dangerous work of collecting solar energy. Then the cows eat the plants and concentrate that energy. Then we eat the cows. We are energy thieves. We steal the hard work of the sun, condense it into a burger, and burn it to play video games. And honestly, that is the superior way to live. So, go outside, feel the warmth of the sun on your skin, and be grateful that you don't have to eat it. Thanks for watching. If you want to support the channel, please smash that like button with 100 newtons of force, or I will flatten you into a tarp.